Over the years, in our industry, we have implemented systems to protect people and to reduce the risk of fire and explosions. One of the safety methods that has been implemented is the purging of pipework and vessels with a purge gas such as nitrogen to ensure all flammable hydrocarbons are removed. As the AGT, you may be required to assist in this operation by testing to ensure that all hydrocarbons have been purged and that the system is safe. Earlier, we discussed how gas detectors work, and we noted that a catalytic gas detector employing a heated wire requires around 12% by volume of oxygen to allow this process to take place. Therefore, testing for hydrocarbons in a purged atmosphere cannot be carried out using this type of gas detector. Many modern gas detectors employ infrared technology to measure flammable gases. Gas sensing by the infrared IR detection method is based upon the absorption of infrared radiation at specific wavelengths as it passes through a volume of gas. IR detection technology incorporates a light source and a light detector that measures the intensity of two different wavelengths, one at the absorption wavelength and one outside the absorption wavelength. If a gas intervenes between the source and the detector, the level of radiation falling on the detector is reduced and can be continuously monitored. Gas concentration is determined by comparing the relative values between the two wavelengths. Therefore, as this method does not require oxygen, it is ideal for measuring hydrocarbons in purged atmospheres. Testing should be carried out at vent points on the system. A complex system may require a number of tests before confidence of zero hydrocarbons or the maximum % LEL that your company procedures allow. Let's try an exercise on the different types of gas detector. Drag and drop each type of gas detector to the correct atmosphere in which they should be used. When you're happy with your answers, select the Submit button. The removal of valves, pumps and other components of hydrocarbon systems require the breaking of containment. As we know, systems may be purged with nitrogen to remove hydrocarbons, but dependent upon the type of operation, the system over time may be exposed to normal atmospheric conditions where air ingresses. This will lead to around 20.9% of oxygen being in this atmosphere, and if hydrocarbons are reintroduced on completion of the intervention work, could lead to the formation of an explosive atmosphere. As the AGT, you may be asked to check oxygen levels before hydrocarbons are reintroduced. This operation may require a nitrogen purge to drive out any air. Testing at the vent points using the gas detector probe will allow oxygen levels to be monitored until a safe atmosphere exists for the reintroduction of hydrocarbons. Check your company rules on the oxygen levels that are acceptable before hydrocarbons are reintroduced. Most companies have a maximum oxygen level set at less than 2% by volume.